All right, stats, welcome, especially for my kids that did not take the quiz today. That means you will not be taking it until November 30th if you were just gone for really only today, or the 2nd or the 3rd if you've been quarantined this whole week. This is the official quiz review. I would use this as well to help you with homework sets number 2. All right, for chapter 10, which I'm going to email you if you've been quarantined, when your due date is. You have a spinner with spaces labeled 1 through 4. All numbers are equally likely to be landed on. You're going to spin it twice and find the sum. All right, so 1, 2, 3, 4. 1, 2, 3, 4. The sum of 1 and 1 is 2. The sum of 3 and 2 is 5, and so forth. X equals the sum. Define X. Find the probability of getting a sum of 5 or more. Probability that X is greater than or equal to 5 would be 4 of those 5 plus 3 of those 6s plus 2 of those 7s plus that 1 8. So that is, explain your reasoning and showing me how you're getting these numbers. 10 out of 16, 5 out of 8.625. Find the probability of getting a sum that is less than 6. So probability X is less than 6 because if you get a sum less than 6, that means less than or equal to 5. And there are 4 5s, 3 4s, 2 3s, and 1 2. So it's the same. Come on here. It's the same probability. And then find the expected value of the sum of the two spins. Well, first off, there are 16 different sum there's. I know a lot of them are repeated, but there's 16 different things going on there in my sample space. All right, the event of getting a 1 and a 2 and a 2 and a 1, we count as different there. So 16 is my denominator. There's 1 2, 2 3s, 3 4s, 4 5s, 3 6s, 2 7s, and 1 8. And I represent, this is just one way. You could also use probabilities. 1 2 plus 2 3s plus 3 4s, dots, plus 1 8. The numerator gives me a sum of 80. 80 divided by 16 is 5. That's how you show it. Show me those calculations. Expected value of X. Pause this whenever you need to. That's how we get 5. All right, up here, X is a day you play. 30% chance of rain Monday, 40% chance of rain Tuesday, 25% chance of rain on Wednesday. If it rains at all, a high school baseball game will get canceled. What's the probability that you will get to play on exactly 2 of these days? So I get to play means it doesn't rain. So 0.70, you're going to be using the complement. If you want to play, you're using the complement of these percents up here. You get to play, you get to play, you don't get to play, so it does rain. You get to play, you don't get to play, so it does rain. You do get to play. You don't get to play, so it does rain. Use that 0.30. Use that 0.60 because it doesn't rain. That's the complement. And then use 0.75 because it doesn't rain. That's the complement. Add them up. Probability you play exactly 2 of the days, 0.450. What's the probability you get to play all 3 days? So it doesn't rain. Use the complement of those percentages up top. 0.70 times 0.60 times 0.75. That's 0.315, almost a third of a chance there. What's the probability you don't get to play at all? So it rains all 3 days. We use all of those percents that were given to us in the problem. 0.30 times 0.40 times 0.25. It's a 3% chance. So what's the probability you get to play at least once? Again, write these probability statements. The probability you get to play at least once. 1 minus the probability you don't get to play at all, which is that. What is the probability that you will get to play on at least 2 of these days? Probability that X is greater than or equal to 2 is the probability that X is 2 plus the probability that X is 3, and it is that. All right? Then here we go. So X is a made free throw. You're an 85% free throw shooter. What's the probability that X is 2? You make them both, 0.85 squared. What's the probability you make exactly 1? You can make it, miss it, make it. That's the probability you make it. That's the probability you miss it. All right, depending on how you round, you can round them both to 128, so you get 256. Or you can just take that 0.1275 and double it. So what is the probability you make at least one free throw? It's, again, you can always do 1 minus the probability you miss them both. You make none. And that's how we get 9, 7, 8. Or in this example, because you're only shooting 2, you already know the probability you make 1. You already know the probability you make them both. That's how you get 0.975 or 8 as well. You're a 76% free throw shooter. You're going to shoot 3. So again, X is a made free throw. This is a new one. So again, X is a made free throw. What's the probability you make them all 3? 0.73 to the third. What's the probability you make at least 2 of the 3? So making greater than or equal to 2 is probability you make 2 plus probability you make 3. So the probability that you make 2 is the following. You can make it, miss it. You can make it, miss it, make it. Again, 0.24 is probability you miss. You can miss it, make it. So you have 3 of the 0.76 squared times 0.24. It's depending on how you round, you get 417 or 416, and add that to the probability of making all 3 that you got in A. That's the probability you make at least 2. Then what's the probability you make at least one of them? That is 1 minus the probability of making 0. Probability of making 0 is 0.24 to the third. 1 minus is that answer. All right, number 5. Calculus 2 at a certain local university reported the following grades from their fall 2016 section. So this is expected value. You know, X is, you don't have to define X here, but X is the GPA. So you get 4 points for an A, and the probability of getting an A is 0.11. That's why I have 4 times that. Plus, you get 3 points for a B. That's the probability of getting a B. Plus 2 points for getting a C. That's the probability of getting a C. 1 point for getting a D. That's the probability. And yes, put this. 0 points for getting an F. That's the probability of getting an F. Add them all up. Basically, C average. Which would probably be okay in a Calc 2 class. Is the overall GPA, believe it or not. Okay, let's talk about non-word errors. X is discrete because, first off, the errors, you make 0 error, you make 1 error, you make 2. It's countable, all right? There's no decimals there for the errors. You can't make 1.7 errors or 1.8. You make either 0, 1, 2. The worst you can do is 250, so it is finite. It is finite. Errors there are countable. It's not a decimal there. Errors, they're all whole numbers, okay? Any of those, that's good. But definitely X is countable. That's what we want. So write the event at least 1 non-word error. So X is greater than or equal to 1, which is 1 minus no errors, which is that. All right, describe the event X is less than or equal to 2 in words. That is 2 or fewer non-word errors. Probability X is less than or equal to 2 would be this plus this plus this. And then what is the probability that X is less than 2? If X is less than 2, you made 0 or 1 errors because, again, you can't make 1.8 errors. Less than 2 means that one and that one. Add both those up, and you get 0.41. All right, let's move on. Everyone in class today finishes pretty quickly, so I think this is one of the nicer quizzes. So if you've been quarantined for a little bit, won't be that bad when you make this up. Choose at random a young adult, age 23 to 26, and then ask them their age and where they live. So this table gives that info. So here, you're pretty much just going to, write what's going on. What is the probability that the person chosen is a 25-year-old who lives at home? That is this right here. We have a 25-year-old living at home. That is that 1 cell. Points. 1-0. All right. What's the probability a person chosen is a 26-year-old? That is this column. Add those 3 up. Probability that they're 26 years old. Add them up. What is the probability that the person chosen lives with their parents? With their parents is this. As you can see, C is this. So this is a column. I don't know if I should have said column here, not a row. This is a row. That row. 0.34. Then D, what's the probability that they don't own their own home? So I need to figure out who owns their own home. That row there. That's the quickest, and subtract it from 1. 34% of people own their own home in this group, so 1 minus that. Then on E, what is the probability that the person chosen is over the age of 24? If they're over the age of 24, why did I put that? That person, what did I do there? Person over, no, that should say older than. So older than 24. The person is older than 20. I don't know why I put 1 minus. It's people older than 24, as you can see here in E. You're going to add up that column and that column. Add it up. If they're older than 24, they're 25 or 26. There you go. Got to be careful on on F here. It's probability of being 26 union apartments, because you could be a 26-year-old living in an apartment or both. So living in an apartment would be this one. Being 26 years old is this one. And, uh-oh, I added the wrong numbers here. I made a boo-boo in mine. You're going to overcount that 0.50, so I can't count it twice. Anyway, I made a mistake here. So first off, this is the probability that they're 26 years old. Very good. But the probabilities for owning your own apartment is that plus 09, and we don't want to count the 05 twice. Don't count that 05 twice. So you can do the probability that they're 26 plus the probability they live in the apartment minus the intersection. That's what we're getting at. We talk a lot about in Chapter 12. So I need to give you this answer instead. This is 20273847, it looks like. So my fault on that. I gave you their owning their own home 1 instead of the apartment. All right, and then here we are with the racing. 3 races on the schedule. Let X be races 1. It's probability of winning no races. So take that probability of winning a race and do the complement. It's the complement of winning the race, and that's the complement of winning the race. Quarter chance, no races. What's the probability of winning 1? At least 1. The probability that X is greater than or equal to 1 is 1 minus the probability of not winning. There we go. What's the probability of winning 2? At least 2 races. So we need the probability of winning 2 plus probability of winning 3. Here's the probability of winning 2. What do we have here? Win, win, don't win. Win, don't win, win. Write them all out. Don't win, win, win. Those are all the probabilities of the things I just mentioned. Add them up. Probability of winning exactly 2 is 0.256. Here's the probability of winning all 3. Probability of winning the first, the second, third, 047. So the probability of winning at least 2 is 303. Find the expected value for the number of races Mr. Yak should win. So expected value, you need the probability of winning 0, 1, 2, and 3. And I have 0, 2, and 3. I need the probability of winning exactly 1. And here it is. This is winning, not winning, not winning. Not winning, winning, not winning, and then not winning, not winning, winning. Multiply and add. Probability of winning exactly 1 race is 447. So for expected value of X, this is the probability of winning 0 races times that value of X, which is 0. Probability of winning 1 race times the value of X, which is 1. Probability of winning 2 races times the value of X, which is 2. Probability of winning 3 races times the value of X, which is 3. Add them all up, 1.1 races. All right, folks, that is your quiz review. We should be ready to handle Chapter 10 when we get back. This is Yak Math Video signing out.